Hello, our team is confirmed by Melissa, Alejandra, and Eduardo. We got the problem number 9, and this is our project.
The function that was given to us is f of x equals x cubic minus x over x. Our restriction is that x cannot be 0. And well, that now our domain is that x is all of the real numbers except 0, and this could be a vertical asymptote.
Well, we have our function, and for the vertical asymptotes and gaps, we need to substitute the value. There is 0 in our function, and we substitute and we obtain there is 0 over 0, that it's a gap. Then we equalize our x to 0, and we have the 1 point, and next we substitute the value in our new function, and we obtain that x is equal to minus 1. So the point of the gap is 0, minus 1.
And to obtain the x-intercept, first we need to substitute the y value to 0, and we obtain two results. That is, x1 is equal to 1 and x2 is equal to minus 1. Then, to obtain the y-intercept, we substitute the x to 0, but we got to the result that x is minus 1, which doesn't exist because it has a gap of 0, minus 1. To obtain the symmetry of the function, we need to substitute the x by minus x. Then our result, it got x squared minus 1, which is even, because even means that the symmetry is to the y-axis.
In order to solve the horizontal asymptote, we compare both sides of the limits of the infinity to the right. So it gave us positive infinity, and then to the left using the minus infinity, which also gave us positive infinity, and the result is that there's no horizontal asymptotes because we have an infinity.
Well, this is our function, and the derivative of that function is 2x. Well, for the ID test, we did a table, and we need to solve by a number that is in negative for minus infinite to 0, and we need to solve also with a number positive that is 0 to infinite. In this case, we choose minus 2, and we substitute the value in our derivative function, and we obtain minus 4. So the function is decreasing. And we choose the value of 2 that is positive, and we substitute that value in our function of derivative, and we obtain 4. So it's increasing. And then we have our derivative, and we equal to 0, and isolate x, and we obtain there is x equal to 0, and this is the critical value.
We substitute the critical value in our function, which is this one, and we obtain that x is equal to minus 1. Then the minimum value that we obtain is 0, minus 1.
For the first derivative of the function, we obtain this result, and then for the second derivative is 2. 0 cannot be 2. So, well, the concavity test cannot be performed. There is no change in concavity, thus there is no reflection point. Then, with the second derivative, it is a positive number. So, concavity goes up because the second derivative is a positive constant.
Well, this is the graph of the function. We have the x-intercept in 1, and minus 1, and the gap that is in minus 1. And the range for the function is y belongs to minus 1, comma, infinity.